This is the third in a series of videos that I'm making for a pre-calculus / math analysis type class, and we're still talking about functions. Here we have the definition of an inverse function, and we say that a function f has an inverse if and only if there exists a function f negative 1 such that f composed with f negative 1 equals x. And we call this f negative 1 f's inverse. Okay, so what do we mean by composed? Well, we say a function is composed within another if it is contained or stuck inside the other function. So here we would say x squared is composed within sine of x because x squared is inside or stuck in where x should be in sine of x. So we would say that x squared is composed within sine of x here. Okay, so let's look at a couple of quick examples. Okay, so this example asks us to find the inverse of f of x equals x squared. Well, how do we want to do that? It sounds a bit weird, but first what we want to do is write out y equals x squared and then switch x and y. Now, why do we want to do that? Well, it's because an inverse function at its heart is really undoing what the function does in the first place. So here, if we take this example where we have yellow as our domain and the red circle as our range, then x would map to a, y would map to 2, and 4 would map to b under this function between the two, which I'll color blue. So through this blue function, x maps to a, y maps to 2, 4 maps to b. But what the inverse does is it maps b back to 4, 2 back to y, and a back to x. And so what the inverse is doing is it's actually making the output the input, and it's making the input the output. So that's why we want to switch x and y here. So now we have x equals y squared. And now we want to solve for y again, just like we do up here where we have y by itself. We want that somewhere down here with y by itself. So how do we do that? Well, we want to take the square root of both sides because y squared is over here. And so now this square root cancels with the power. And we are left with the square root of x equals y, or y equals the square root of x. Okay, but let's look at what we've done here. We found the function, the square root of x, that when you compose x squared inside of it, you get the following function. So if we compose the inverse within the function, we get the square root of x, that's from down here, inside x squared. So we put the inverse in where x is in our original function. But now look, the squared cancels with the square root, and we are left with x, which is what we require for the definition of our inverse. And so we have found our inverse function, which is the square root of x. Okay, let's take a look at one more, a little bit trickier example. Okay, so here we are asked to find the inverse of y equals x cubed plus 4 over 5. And this y could very easily be changed with f of x, but I started it with y just to skip that first step of replacing f of x with y. Okay, so what do we want to do first here? Well, first, again, we want to switch x and y because what we're doing is we're making the output the input and the input the output. That's what the definition of an inverse is. So first we want to change those two. So we have x equals y cubed plus 4 over 5. Okay, nice. Now we want to get y by itself. So let's multiply both sides by 5. That gives us 5x equals y cubed plus 4. Now let's subtract 4 from both sides. That gives us 5x minus 4 equals y cubed. And now finally, let's take the cube root of both sides. So we have y equals the cube root of 5x minus 4. And this is a cube root here. Okay, great. Now again, we can check this by composing this function within this function down here and replacing this for x here. Or we can actually do it backwards and take this function, which I will highlight in orange, the inverse that we found, and we can compose this within this function and replace it for x in here. But I'll leave you guys that as homework, and let me know in the comments if this does indeed work. Okay, and that's enough for now.